Okay, next one, example at the moon has a mass of 7.35 exponent 22 kg and a radius of 1740 km. A probe of mass 100 kg is dropped from a height of 1 km onto the moon's surface. Calculate its change in gravitational potential energy. So we are given the moon here, okay, with a mass of this one, and then radius of this one, and then we have a probe with mass 100 kg is dropped from a height of 1 km. So we have an object here which is at the height of 1 km, and then it is dropped onto the moon's surface. So meaning that now it is on the moon's surface here. Okay, so this object with mass 100 kg. Now we want to calculate the change in gravitational potential energy. Okay, we want to calculate the change. So change here meaning that we need to find the differences. Okay, kita akan tolak dua value. So value apa? Value potential energy. So delta U, always use the delta U whenever we want to calculate a change. So delta U is equal to U final minus U initial. Dia mestilah final minus initial. So mana satu final, mana satu initial. So initially, okay, objek tu berada 1 km di atas permukaan bulan. So this is the initial situation. So this one is the final. Final selepas dia jatuh di permukaan bulan. Okay, so this one you just masukkan formula untuk potential energy, di mana we have negative GMM divided by R final minus GMM divided by R initial. Okay, so initial kita adalah kamu kena tambah dengan the radius of the moon. So the R initial here, the height of the moon plus the radius of the moon. The height of the object here. Di mana untuk final, since dia adalah berada sudah dekat permukaan kan, so radius dia akan sama dengan radius of the moon. So this is the radius of the moon, this is the mass of the moon. Okay, so now since all of these are constant, initial dan final mass tidak akan berubah. So yang berubah hanyalah the value for R here. So untuk senangkan kita just factorize sahaja, keluarkan value yang sama which is GMM. So kita ada 6.67 exponent negative 11. Mass of the moon, and then mass of the object 100 kg, and then barulah kita masukkan this one. So don't forget the negative here, negative 1 over R final, which is this one, equal to this one, 1740. So kilometer convert to meter, minus, so tambah 1 over the initial, which is this one. So kena tambah dengan 1 km. So bermaksud 1741 exponent 3. And then tekan calculator, you will get it will be equal to negative 1.62 exponent 5 joule. So this one soalan A. Okay, now soalan B. If all the gravitational potential energy loss is converted to kinetic energy, calculate the speed at which the probe hits the surface. So dia bagi tahu sini potential energy loss ni sudah di-convert ke kinetic energy. And then what we want is the speed at which the probe hits the surface. So dekat situation di sini. Okay, di mana probe ni sudah hits the surface. So we want to find the speed here. This value for V. Okay, so now based on this information, kita tahu potential energy loss is converted to kinetic energy. So all the potential, kan dia cakap all the potential energy loss, maksudnya initial dan final energy loss, which is this one, this value here actually. So delta U is now converted to kinetic energy. Okay, so we want, and we know that kinetic energy is equal to half mv square. So this one you just masukkan to here, 1.62 exponent 5. Okay, you don't need to include the negative because this negative, because energy is scalar quantity, it's not vector quantity. So masukkan 1/2 mass. Mass of what? Mass of the probe, because they minta speed of the probe. So mass of the probe is 100, and then v square, and then you will get the speed is equal to 56.92 meter per second. Okay, next one, example 9. A space station of mass 400,000 kg orbits the Earth at a height of 36,000 km above the Earth's surface. What are the gravitational potential energy of the space station? Okay, so we have the Earth here, and then we have the space station, okay, orbits around the Earth. So this space station is at a height of 36,000 km. So this is the space station at a height of 36,000 km, and then it has mass of 400,000 kg. So what are the gravitational potential energy of the space station? So this one straightforward. Keluarkan formula untuk potential energy, negative G mm divided by R. So masukkan sahaja value for G, 6.67 exponent negative 11, and then mass of the Earth, which is 5.98 exponent 24, and then radius of the Earth, mass of the space station dulu. Mass of the space station 400,000 kg, and then radius of the Earth tambah dengan height. Okay, because the value for R here must be, okay, the value for R here must be from the space station to the center of the Earth. So this one tambah with this one, which is 6.38 exponent 6 tambah dengan 36000, and don't forget to convert to meter. So you will get it will be negative negative 3.76 exponent 12 joule.